You ever wonder how doctors can, listen to what a bladder is actually trying to tell them? Well, today we're going to decode something called urodynamics. It's this amazing set of tests that basically translates your bladder's function into a language we can all understand. So, this is what we're talking about, a urodynamic tracing. And yeah, I know, to most of us it just looks like a crazy tangle of lines. But believe it or not, hidden in all that data are the secrets of how a bladder is working, or sometimes not working. It is absolutely packed with info on pressures, flows, volumes, and our job today is to figure out how to make sense of it all. Which, brings us to the big question, right? With all these squiggly lines and numbers, how in the world does a doctor turn all this complexity into a clear, actual diagnosis? Well, luckily for us, there's a system for that. So, to get a handle on that system, we first have to really know what we're looking at. You can think of it like a secret language of the bladder. And urodynamics? That's our translator. Okay, so what is it exactly? Well, urodynamics is basically the dynamic study of how urine gets transported, stored, and then evacuated. Honestly, the best way to think about it is like a complete performance review for your bladder. It's checking everything. And here's the thing. A single one of these tests, it generates a huge amount of data. So the only way to tackle it is to be systematic. It's just like how a radiologist has a specific method for reading an X-ray, right? Well, doctors who do this have a framework to make sure absolutely nothing important gets missed. And that framework? It's actually brilliantly simple to remember. It's called the 9 C's, and it's going to be our guide for cracking this code. So here they are, the 9 C's. They're split really neatly into the bladder's 2 main jobs, right? You've got filling and storage on one side. That's the first 5 C's. And then you have emptying on the other. That covers the last 4. So let's dive in and start with that first phase. Okay, let's kick things off with the filling phase. This is all about what's happening from the second the bladder starts to fill up all the way until the patient gets the green light to go. First up is coarse sensation. Now this one is all about what the patient is actually feeling as their bladder fills up. And yeah, it's subjective, it's based on their personal feeling, but it's an absolutely crucial first clue for understanding that nerve signaling between the brain and the bladder. And what's so cool is how we can map those feelings, those subjective points, directly onto the data. Take a look at the points marked on this tracing. You can see first sensation, then first desire to void, and finally, strong desire. When you pair those markers with the volume data, it tells you a whole story about whether the bladder's communication system is really working the way it's supposed to. All right, next up is number 2, compliance. The best way to think about this is to picture a balloon. A healthy bladder is like a really, really stretchy balloon. It can hold more and more fluid without the pressure inside just shooting through the roof. And this tracing right here, it's a perfect illustration of what happens when compliance is poor. So as the volume fills up, you can see that on the bottom line, it's rising. Just look at the detrusor pressure. That's the green line. See how it just climbs and climbs? That is a stiff, non-compliant bladder. And that sustained high pressure, that is a major risk factor for kidney damage. Really serious stuff. Okay, our third C is contractions. Now, during the filling phase, the bladder muscle is supposed to be totally relaxed, just chilling out. But if it starts squeezing when it's not supposed to, involuntarily, that's what we call detrusor overactivity, or DO for short. And on a tracing, you see these as sharp spikes in pressure right when there shouldn't be it. Next on the list, we measure systometric capacity. Now, this isn't just about that first little urge to go. This is the volume where the patient feels like, okay, I cannot delay this any longer, I have to go. It's basically the bladder's max capacity from the patient's point of view during the test. And the final C for the filling phase is continence. And the core question here is super simple. Is the patient leaking any urine? That's it. So during the test, we'll actually have them cough or do other things to see if we can provoke a leak so we can understand exactly when and why it's happening. Oh, this is a fantastic comparison. Look at the tracing on the left. You see those sharp green peaks? Those are those involuntary bladder squeezes we talked about, and they're causing leakage. That's urge incontinence. Now, look over to the right. Here, the pressure spikes are caused by coughs, and you see the leak happen right after. That is classic stress incontinence. 2 different problems shown so clearly. All right, so that covers the whole filling and storage part of the test. Now the patient gets the okay to go, and we shift our focus to the final 4 C's, all about the emptying phase. Coming in at number 6 is contractility. This is all about measuring how strong and sustained that bladder muscle squeeze is when it's actually time to empty. Is it a good, strong, efficient squeeze, or is it kind of weak and underactive? The seventh C is coordination. And for urination to happen smoothly, you got to think of it like a dance. It's all about timing. The pelvic floor muscles have to relax just before the bladder contracts. If they don't, things get messy. It's all about teamwork. And here is what that perfect dance looks like in real life. This is a fluoroscopy image, and it shows the bladder neck opening up into this wide funnel shape. That is the sign of perfect coordination. It means urine can just pass right through without any resistance at all. Our eighth C is complete emptying. It's a pretty straightforward question. After they've gone, is the bladder actually empty? We measure this with something called the post-void residual, or PVR, which is just the amount of urine that got left behind. And that brings us to our final C, clinical obstruction. This is your classic plumbing problem. Is there a blockage somewhere? In urodynamics terms, we see this when there's high bladder pressure but a really low urine flow rate. The bladder is pushing super hard, but not much is actually coming out.
Wow. Okay, this slide is the perfect example. Look at the graph up top. The green pressure line shows a really strong bladder contraction, right? But the red flow line, it's totally flat. It's at 0. So why? Well, the image below tells the whole story. The bladder neck is clamped shut. That is a textbook case of a primary bladder neck obstruction. No doubt about it.
So there you have it. We've walked through all 9 Cs. But so what? Why is having a system like this so important? Well, the crucial point, and the source material says this perfectly, is that being systematic is really the only way to properly and completely get all the information out of the study. This checklist approach, it stops doctors from getting tunnel vision, from just focusing on the one obvious problem. It makes sure they don't miss other, more subtle findings that might be absolutely critical for the patient.
It really makes you think, doesn't it? You take this simple, memorable checklist, and it transforms a super complex test into a clear, comprehensive story. And it kind of leaves me wondering, what other complicated areas of medicine out there could be made safer and a whole lot clearer with a simple, elegant system just like this one?